Hello guys, welcome back to the channel. So in today's video, we're going to continue with building basically our introduction to agentic AI systems course. So in this video, we're going to be looking at specifically how to work with chains in LangGraph. Okay. So let's take a look at the course overview. So basically in the last video, we covered the very basics of how agents work, right? The very fundamental basic. We talk about different what are agents, what are nodes, and all those are fundamental stuff, right? So in today's video, we're going to take things a bit further. We're going to learn how to work with chains, and we're going to learn how to work with different chat messages, different tools, how to create our own tools, basically working with chat models, and also how to execute these tools and do different stuff. Okay, so that's what we're going to be covering in this video. So let's get into it. So you're going to okay. Let me just again. Just cover. I've already mentioned it, but let's just cover it again. So we're looking at chat messages, learning how to work with chat messages. We're looking at chat models. Basically, these are just LLMs with chat capability. We're also going to be looking at how to work with create our own tools and how to use these tools to interact with the external world or do different stuff, right? So we're going to also look at using messages as states or for our graph. You are using a reducer. You're going to look at what a reducer is. Again, these are new concepts, so don't worry if you don't understand. It's all fine. And then you're going to put everything together into building a simple agent. Okay, so let's start with chat messages. So what are chat messages? So basically, a chat message are structured objects used to represent different types of conversational exchanges in LangChain. So we can have different types of conversation exchange. Like if you go on, let's use a tool like ChatGPT. If you go in there and you type in something, that's a human message from the perspective uh, of LangGraph or LangChain in general. That's a human message, and then you get an AI to respond back to you. The response back is now an AI message, right? So these are just different classes that LangChain has or LangGraph has that you can use to interact with basically the chat models or the LLMs. So there are different types of chat messages. So there are system messages, which is basically your prompt you use to prompt the LLM, basically on maybe on how to behave, right? So we can tell LLM to behave uh, like let's say a YouTuber, right? You can tell the LM to behave like a singer, to behave maybe like maybe a joker to tell jokes. So that's a system prompt, right? So we also have human messages, and then human messages are basically messages that you type into the system are called human messages. We also have the AI message, and as the name says, an AI message. The response from the AI, from the large language models, is what we call AI message. We also have multi-modality messages and different types of other message types that we have. Okay, so that's basically it. So these are the basics ones. You can take a look at the official documentation on this, and I'm going to have a link drop on the description so you guys can check that out. Okay, so now let's talk about chat models. So what is a chat model? So basically a chat model is just an LLM that is being fine-tuned to be able to have chat conversations, right? So just a large language model that has been fine-tuned or trained to be able to have chat conversation back and forth. So it takes in a bunch of messages and it responds back those messages, right? So it can have chat capabilities. That's basically it. An LLM with chat capabilities is what we call a chat model. Okay, so there are different chat models that we have, and you're going to use them later on in the future. So for now, let's just skip over these chat messages. We'll come back to them just in other videos. So we've already talked about tools. So tools are just the Python functions that help the LLM to interact with the external world or to carry out something. So let's say you want to build an agent that can search things on the internet. So we're going to create a tool that can enable this agent to search things on the internet. Think of yourself as a human, right? You can't go and search things on the internet without using a browser, right? So a browser is a tool that you use to search things on the internet. So that's basically a tool to an agent. So this tool helps the agents to do different stuff, right? Such as interacting with the real world. You can write a Python function that controls maybe an Arduino or like a microprocessor. So one thing happens and then the agent reacts. Or you can write a tool that helps the agent to search things on the internet. You can write a Python function that helps the agent to perform mathematical calculations. You can write a Python function, which is basically a tool that helps the agent to call an external API. So it helps the agents, the AI models, to interact with things that are within the external world. So you can also write a Python function and connect it to a microprocessor, and that can turn on the lights on and off in your room. And that function can get called by the LLM or the chat AI, and then in basically turn on or turn on or turn off the light within your room. That's one possibility. So we're also going to look at, once we have all this done, yeah, we've looked at the different types of messages. So let's take a look at, let's go back in here and let's take a look at these chat models, and let's see how you can work with the different chat models that we have. Okay, so let's go ahead and first start with the messages, the type of different chat messages. Okay, so I hope that whatever explanation I've given you so far gives you a basic foundation. So now let's build up upon that foundation with code. Okay, so now I'm just going to go ahead and I'm going to go ahead and show you how to create a chat message. So I'm going to go into my Jupyter notebook, and I have a file there called buildingchains.ipynb. Okay, and I've made sure that you have the right environment selected. So once you have all that selected, I'm going to go ahead and import a couple of things. So I'm going to say from, okay, I need this to be a Python cell. So I'm going to say from LangChain underscore core dot messages. I'm going to go ahead and import the human message as we discussed. So that's basically the message from the human. So human message, and you're also going to go ahead and import one more thing, which is the AI message, basically the response from the AI. So I'm also going to import pretty printed. I'm going to import pretty printed just to help us to print things out within the terminal. Okay, so once I have those imported, I'm going to go ahead and create a messages variable, which is going to be basically a Python list. So I put a Python list right here, and I'm going to go ahead and add in an AI message. So I'm going to pretend this message came from the AI itself, right? So I'm going to go ahead and say, hello, how are you, or how can I help you today? Typical ChatGPT message, right? And then basically you're going to give this a name. So the name of this is going to be from the LLM. So you can give it any name that you want. Okay. So that's basically, so I've created a simple chat, created a simple list right here assigned to a variable called messages. In there we have an AI message. That's basically a response from an LLM or an AI model. Okay. So now we're going to go ahead and add more stuff into these messages and see. So I'm going to say messages, messages.extend, and you're going to go ahead and add in more stuff in here. So we're going to extend this, you're going to add in another list. And this is going to be a human message. We're going to provide in the content, and it's going to basically say, I'm fine, thank you. Basically, I'm fine, thank you. Just like that. And then we're going to give it a name. So name, and you're going to give a name of human, just like that. Okay. So once we have that, now we can replicate this a couple more times. So let's just simulate a simple conversation between an AI and a human. So the human says, the AI message says, hello, how can I help you? And the human says, I'm fine, thank you. And then the AI message can go ahead and respond. So let's say that this is the AI message, the AI model, and it says, great, I'm fine, I'm fine too. Okay. Yeah, so that's basically it. And you can say how is work going on your end. Basically you're just trying to simulate kind of a conversation between an AI and a human. So say, how is work going today? That's the question from the AI model. So this is now the LLM. So the LLM again, and then you're going to copy this and duplicate it one more time, and this is now the human respond. And now we need to go ahead and change this now to be an AI message, because it's now from the AI, and now the human is going to respond, great, all is fine on my end. Okay, that's a full stop, and then basically it's going to be from the human. That's basically, so once we have this created, you just simulated a conversation between a large language model and a human. So the large language model says, hello, how can I help you today? The human responds, I'm fine, thank you. And then the AI goes, great, I'm fine too. How is work going on your end? And the human responds, great, all is fine on my end. It's a simple conversation, right? So now let's try to print this out. So once I have this, I'm going to run this cell. Okay, let's see where I made an error. So it says incomplete output. So let me see. Okay, I need to close off this and then run that again. So good. So once I have that, I'm going to go ahead and say for m in messages, for message in messages, you're going to go ahead and simply do m dot pretty print, and then simply print this out. So you can see the message right here. So the LM goes, how are you? Hello, how can I help you today? The human response, I'm fine, thank you. And then the LM goes, great, I'm fine too. How is work going on going today? And then the human says, great, all is fine on my end. That's basically a simple conversation between a human and an LLM. But in real world cases, you wouldn't be going ahead and typing the AI's response, right? So that's where the large language models come in this video. I'm not going to look at these large language models at this moment. We'll look at it in the next video. Okay, so right now we're just trying to simulate the things manually. Okay, good. So now once you've looked at that, let's move on and look into chat models. Okay, so basically chat models are just LLM that has been fine-tuned for chat capability, so they can take in a collection of chat history like the way we have right here, and then basing on that can respond. Okay, so I'm going to go ahead and say from LangChain, LangChain underscore open AI. I'm going to go ahead and import the following. I'm going to go ahead and import. Okay, I'm going to use Anthropic in this case. I'm going to say Anthropic. I'm going to go ahead and import chat Anthropic. Okay, so once I have chat Anthropic imported, I'm going to go ahead and create a model. I'm going to call it a model, and the model is going to be equals to the chat Anthropic in here. And you're going to go ahead and specify the model, and you specify the model right here. So you need to pass in the model name. Once you have the model name specified, we also need one more thing. You need an API key. So you need to go ahead, create an Anthropic account, and then get an API key. So once you get an API key, you come in here, go ahead and say, create a file called .env, and you're going to say Anthropic underscore API underscore key, and then equals to, and then we're going to go ahead and paste in your Anthropic key right here. So this will be your Anthropic key, whatever it is, right? So make sure that you have your Anthropic key and you have it pasted in right here. Okay, so I'm going to leave the link to where you can get this Anthropic key, and once you have it, you're going to add it in right here. Once you have that done, you also need to install one more library. So I'm going to go in here and I'm going to do a pip install python -dot .env. We need to install python.env, okay, for this to work. So make sure that you go ahead and install python.env, and this library is going to help us to read environment variables within our Python code. Okay, so just run this command pip, make sure you have the exclamation, and this is a Python cell, and then say pip install python-.env. So this is going to help us to read environment variables from our env file, which is basically our API key, in this case our Anthropic API key. So make sure that you follow the link. I'm going to just go online and just search for Anthropic API key, and then create an API key. And then once you have the API key, go ahead and add the API key in here. Okay, and I'm going to leave a link to basically how to create an account on Anthropic in the description of the video. So make sure that you go ahead and do that, and I'm going to go ahead and delete this for now because we have that installed. Okay, let me just comment it out. It's also fine. Okay, so make sure that you have Anthropic key inserted. So let me just go ahead and get my Anthropic key, add it to my env, and then I'll be back recording. Okay guys, so I have my Anthropic key already added into my my .env file, so I can open up my .env file because I don't want to expose my Anthropic key. And then you also need to have, if you're going to push this to GitHub, make sure that you create a file called .gitignore, and then once you create a file, just call it .gitignore. And once you have this file, you need to copy and paste in some content to avoid pushing this .env file into production, and also your virtual environment into production. Sorry, into version control, because you don't want to push, obviously don't want to expose your Anthropic API key to anyone, right? So to do that, you can just go online and then search for this website called gitignore.io. And once you search for gitignore.io, go in here and then type in the language that you're using. In this case, you're using Python, and then press enter and then click on create, and that's going to go ahead and create for you this. So copy all this and then go ahead and paste it inside of your .env file. I already have that done, so it's going to prevent pushing things like my .env file and my virtual environment to GitHub. Okay, so once we have that done, now let's go ahead and simply load in basically our virtual environment variables in this case, so which is just our Anthropic API key. So basically load in virtual environment. So I'm going to create a code here, and I'm going to use the following. So I'm going to go ahead and simply say from .env, I'm going to go ahead and import load env, and I'm also going to go ahead and import, yeah, that's all I need for now. And once I have it, I'm going to create a new cell below that, and I'm going to go ahead and say the following. So I'm going to use the percentage sign, and I'm going to simply say reload txt and then say dot env. That's all I want. And I'm going to say down, I'm going to say dollars, the percentage sign, I'm going to say dot env, just like that, and press enter. So this is going to load in the environment variables from in here into our Python application that we can get access to. So in here, I need to go ahead and specify two things. I need to specify the model, and you can just go online and then search for this anthropic model. So let's say anthropic models. Just press enter and then click on this, and you see the different models that anthropic comes with. Okay, so you pick a model that you want to use and just use that specific model. So my internet seems to be a bit slow today. So while that's loading, we can go in here and supply in our API underscore key, and our API key is going to be equals to, we need to import OS as well. So I'm going to go up here, and I'm going to go ahead and import OS library from Python. I'm going to say os dot environment dot get, and I'm going to go ahead and specify our anthropic API key. So this is the same name that you specified inside of your .env file. So you specify something and then equals to, so it's going to be something like this. So you specify maybe anthropic API underscore key, and then equals to, and then you add your API key right here. So this is what we want, this name before the equal marks. Okay, so let's paste that in here. So anthropic underscore API underscore key, that's what you want to read from our environment variable. So let's go ahead and get the model name and see which model. So you can see the different models right here. I'm gonna be using this one right here, Sonnet model. So copy that, and I'm going to go in here and paste that as my model name. Okay, so let me break this into multiple lines. So that's basically how to create a model. You run this and it's going to go ahead and create the model perfectly. So once we have the model created, we are good to go. So the next step is, this is now our chat model. Okay, so we talk about chat models, and that's how you can create a chat model. Okay, so let's go ahead and try to invoke this chat model by passing in this chat message that we have above here. Okay, and let's see what response we get back. So let's say results is equals to model dot invoke. We're going to go ahead and pass in our messages right here. So pass in our messages, which is the message that we created above ourselves, and let's see what we get back. So I'm going to go ahead and simply say print, and I'm going to go ahead and say print result. It's going to be result, and then finally I'm going to go ahead and print those results out. Okay, so just keeping just a bit of decorations right here, and I'm going to go ahead and simply print results dot result response metadata, and let's run that and let's see what we get back. So you can see we got this model got called and it returns to us an output back. Okay, so if you go, you can see how much tokens have been used and all that. So you can see which model we have used as well. I think you also go ahead and get the content right here, and let's see what we get back. So you can see this is the content, which is basically the response from the AI message. It says now this is the response from the anthropic model itself. It says, glad to hear everything is going well. Is there anything specific you would like to discuss, or any way I can help you today? Right, that's from the model. So basing on this chat we have created ourselves, passing this into our chat model, the chat model now continues the conversations and returns to us a response back. Awesome. So once we have that done, let's move on and let's look at something different. And now let's look at we have looked at chat models already. Now let's look at tools. So I've already told you what a tool is, right? So I'm just going to go here and implement whatever we have discussed so far. So tools are just basically Python functions. So we're going to go ahead and create a Python function right here. We're going to call it addition tool. Let's call it addition, takes in A and B, which are basically integers, and returns also an integer, which is the sum of those two numbers. So basically we're going to provide a doc string to this function. So these doc strings are very, very important because they tell the LLM what this tool can be used for. So a tool description is what you pass into the doc string. So every time you're creating a tool using a Python function, you must pass in a doc string, because it tells the LLM what this tool can be used to do. So we're going to pass in this tool. This tool is to be used to add two numbers together. That's basically it. So once I have it done, I'm going to simply return A plus B. That's it. So once you have the tool function created, now we can now add this tool to our chat model so that our chat model can call this tool. So we're going to go ahead and simply say model is going to be, you have already created a model already. So we're going to say model underscore with, well, let me just call it LLM with tool. So LLM underscore with underscore tool is going to be equals to model dot bind tools. You're going to go ahead and pass in a list of these tools. So call this then pass in a tool. So in this case, you're going to pass in our addition tool. So this needs to be a list of tools, but since you have only one tool, I created a list and added in the specific tool. Okay, so once I have that, I'm going to execute that. So now our LLM or our chat model has an access to this tool. So I'm going to say LLM with underscore tool underscore response is going to be equals to LLM with tool dot invoke. You're going to go ahead and pass in a message right here. So again, this message are just basically messages. So we're going to create a human message because we want to pass something to this LLM. We're going to say content. The content is going to be equals to, and you're going to say what, just get that, what is the sum of 10 and 20? That should be 30, right? So we're going to go ahead and pass in that, pass in name, and name is going to be, sorry, this is actually name, so my bad. And this is actually name, and name is going to be equals to, and I'm going to say I'm going to use Prince, right? So code with Prince, and then I have to close off this parenthesis. So I'm going to go ahead and close off first this, then this. I think I made a mistake right here. So human message goes ahead. Let me see, just invoke. Okay, I need to delete this right here. Okay, now that should solve it. So basically, you're just making a call to this LLM and passing in a human message, basically a message from us, and asking it what's the product, the sum of 10 and 20. So let's see what we get back. And I'm going to go ahead and simply print these results again. So print, and I'm going to say results. This is going to be results, and then I'm going to go ahead and print that result down here. So I'm going to go ahead and just add in some decorations right here. And once I have that, I'm going to go down here and do print. So I'm going to go ahead and simply print out the LLM response, and let's see what we get back. So LLM response dot let's just print it out and see what we get back. So we get back this whole thing here, which is a content, has a text. I will help you add the two numbers, and you can see all those information. You can see it's calling a tool and then passing in the inputs, A as 10 and B as 20, calling in our addition tool, and then finally you can see the different tool use. Right now you can see all that information. So basically it's just performing tool use right here. Okay, that's basically what it's doing. So yeah, we now have a chat model, our tool attached to our chat model. So now we can call the chat model and passing in the tool. So that's how we can create a simple tool. Okay, and this tool can be used to do different things. Right now I'm just showing you a simple addition thing. You can connect it with external APIs. You can connect it with your Excel file. You can do just anything that a Python function can do, you can do with a tool. Okay, so now let's look at using messages as states of our graph. So we talked about what a state is in the last video. So we're going to go ahead and see how we can use messages that we have created in this video so far as a state within your graph. Okay, so let's go in here, and I'm going to go ahead and add in here. So I'm going to go ahead and say using messages as state. Okay, so now I'm going to go in here. So what I'm going to be going to go ahead and do is the following. So I'm going to go ahead and import a couple of things. So I'm going to say from LangChain underscore core dot messages. I'm going to go ahead and import any. I'm going to import any. Okay, so it's a type of message. I'm going to say from typing. I'm going to go ahead and import type dict. And we talked about all this in the last video. Okay, so I'm not going to go ahead into depth on these things. So I'm going to go ahead and create a class right here, which is going to be called message state, and it's going to take in a type dict class. It's going to inherit from it, and we're going to have a key called messages, and this is going to be of type list of any messages. So any could be either AI messages, system messages, or any kind of message. So that's basically what any message does. So once we have this, now we can just basically use this as a state to our graph, and you have covered a bit of this in the last video, right? So in this video I wanted to talk about something very, very important, which is called a reducer. So that's why I have this created before we talk about the reducer. So reducers basically help us to work with message state reducers. That's basically what a reducer does. So let me just explain to you from the last video what we understood about how each node works in a graph or within an agentic graph. So basically, let's say that we have a message initially as having the key of message being value is hello. Right? So a key is message, its value is hello. And if we pass it to node 1, we get message hello node 1. So let's say node 1, whenever we pass this message to a given node, the message it just simply add in hello and then the node's name. That's what each of this node does. So node 1, if it gets a message, just simply return hello node 1. Node 2 will return hello node 2. Node 3 will return hello node 3. So this is the message state of our graph. So we pass it initially just having just hello. We pass it through node 1, it gets updated. So the older content, which was just hello, gets overridden, right? Overwritten by the new message from node 1. And even when it goes to pass this state to node 2, it overwrites it again. So it overwrites the message, the value of the message key. And if we pass it to node 3, again, that value gets overridden. So each time we pass the message state to a node, the node overrides the content of that message state of our whole graph, right? And we discussed this in the last video. So what this is not really effective, right? So like the agent doesn't remember anything previous that happened previously, right? So sometimes you need to keep track of these messages in order to give basically each node, not really the node itself, but basically to give an LLM a history or a memory that it can remember. Like if I ask it node 3 what was said previously, it couldn't remember anything because it's just overriding stuff each and every time, right? So to avoid this issue, we can have a reducer so the agent can have a bit of memory. In that reducer, you can store all the previous messages so the agent can know the flow of the conversation, can know the previous messages. But that also has an issue. But let me explain to you right now. We're just keeping a list of all the previous messages. So this is the state. It goes to node 1. Node 1, instead of deleting and overriding the previous state, it simply adds a new state to our graph state. So we have a list, and the list gets updated each time it passes to a different node. So from here it goes to node 1 and it gets updated with the old message exists, and we are simply adding a new message which is hello node 1. So it is hello from the previous, and then hello node 1, which is the update made by node 1. And if it goes to node 2, we still keep the first message, we keep the second message from node 1, and we simply add in the message from node 2. So we're not deleting any previous conversations, we are simply adding new conversations to it. So if it goes to node 3, the previous ones, the first remains, this one remains, this one also remains. The only difference that happens is that we add to it node 3 and says hello node 3, right? So we're not deleting previous messages, we're just appending new messages to it, right? But this also has an issue. LLMs have an issue or a limitation which is called the context window. It's the amount of text or amount of information that they can work with at a given point in time. So it's called the context window limits, right? So each model that you are using has its own limit of how much words or how much text or how much data it can work with at any given point or any given instance. So if you are keeping a list of all the messages, then eventually you're going to overflow that context window of that large language model. So the different techniques of doing this, you can decide to keep the last 5 messages. Other people, you can use also have a running summary of the previous messages. So instead of having all this, you just have a summary of all the previous conversations in just one section, instead of having all the sections of all the previous conversations. So that's what reducers can help us to do. In this case, I'm only going to show you the basic application of a reducer, which is just basically this flow right here, appending new messages onto the graph state instead of overriding the graph state each time the graph state gets passed to a node. The node simply appends to it, right? Yeah, so I just want us to go ahead and I'll show you basically how we can do exactly what I have described here. We're just appending new messages instead of deleting overriding the older messages each time we pass through a different node. Okay, so let's try to do that right here. So to do that right here, we have we're going to go ahead and update this. We did this in the last video, so we're going to go ahead and make some updates to this. So I'm going to go ahead and import one reducer that comes pre-built into from LangChain, from LangGraph, sorry, that you can use. So I'm going to say from LangGraph, I'm going to say LangGraph dot, it's going to be graph dot messages. I'm going to go ahead and import add underscore message. So this is one of the reducers that LangChain comes with. So I'm also going to import annotated right here, annotated right here. Okay, so once I have it, I'm going to run this. And now let's update this that we did from the previous video. We work with this. And now let me show you how to update this. So instead of having this, I'm just simply going to go ahead and cut this off. Sorry, I'm going to undo that. Okay, so I'm going to go ahead and simply cut this off. And I'm going to say annotated. And once I have annotated, I'm going to pass in, I just paste in what I have previously. So annotated takes in a list, and then we have a list of any message, and we also have the reducer function. So this function will be called, and it's each time we want to update the graph state, right? So the graph state is the initial graph state, and when we pass to node 1, that add message function will be called. We simply prevents overriding the previous message and simply adds the current message to it. And if we go here, the current all the previous ones who exist, we just append. We go to node 3, we just append a message of node 3. We don't delete the previous ones. That's what this add reducer, add underscore message reducer does. Just simply add things to it. So this is a built-in from LangChain. You can also define your own reducers. Okay. So once we have this done, and we're going to go ahead and simply say messages is going to be equals to, we're going to go ahead and create a simple list of messages right here. And I'm going to create a human message. I'm going to say content, and I'm going to go ahead and simply say hello. This is a human message. We're going to say how you're doing. Okay. And you're going to go ahead and give it a name right here. And the name is going to be simply human. Let's say Prince. You can use any name that you want. It really doesn't really matter. So the AI, you're going to also going to have an AI message, and it's going to have a content, and this is the AI responding to me. So hello Prince, I'm fine. I'm fine. Fine. Thank you. That's it. And then you're going to give it a name right here, and name is going to be the LLM. So LLM. That's basically it. Okay, so I have these two messages, just very plain and simple. So once I have these two messages, let me run this. Okay, those two messages have been created. So now let's go ahead and create an additional message. So let's say additional underscore message, or a new message is going to be equals to, you're going to go ahead and create a list right here. We're going to say the human message. Now this is going to be my response, right? So my response, I'm going to say I am fine. I'm fine too. How is work on your end? Okay, this is some message. There's some text I have written down. So okay, so once I have it, I'm going to give it a name, and the name is going to be again Prince. Prince, right? So that's basically it. Okay, and you're going to go ahead and update our current message with the additional message that comes in. So for now, let's go ahead and do something. Let's simply print the add underscore. Let's simply print the messages, and let's see what we have. So print messages. For now, we have only 2, right? Or I can just go to and say for message, for m in messages, print m, can say m.pretty printed, and just run that. So you can see message by Prince, how are you doing? And then the LM response, hello Prince, I'm fine, thank you. Good. So that's what we have right now as messages. So now let's see how we can update this. So we're going to go ahead and simply do the following. It's going to say add underscore messages. You're going to add in for our messages that we have. You're going to go ahead and add in our additional message that we have. Okay, so run that. And if I go ahead and do, let me just go ahead and copy this right here. Copy this and then go ahead and simply run it right here. Now you can see we have, okay, I have to assign this back to additional variable. So for now, let me just go ahead and print it out instead of having to assign it to original message variable. So if I print out, you can see we have right here. So if I scroll all the way, you can see we have simply added. Let me see what we have said here. So I'm fine, thank you. And let's see what we have right here. So we're just simply adding So add a message, you're passing the messages and then additional messages. So if you go in here, we can assign, let me just assign this to, let's say, updated messages, message, and it's going to be equals to this, and let's run this, and then let's say updated, update message, and let's see what you get. So you can see the updated message. So you can see hello there, and then we have this one being added to it at the bottom right here. Good. So that's basically how we can use reducers to define basically how the state or our graph state gets updated, right? Basically acting as a memory to our agent. So in this case, you're simply adding, if you add in a new message text, it will simply just append it to the existing one. It won't delete the older ones. It will just add it to them, right? So that's basically how a reducers work, and you've just implemented this logic that we have in here. Okay, good. So now now let's go ahead and do the final part, which is just putting everything together before we end the video. So let's go in and do it right here. So we're going to go ahead and say I'm going to go in and say simply say putting it all together, and let me run this right here. So I'm going to go ahead and simply create a function right here, and this function is just going to go ahead and simply we're going to call it tool underscore calling underscore LLM. We're going to pass in our state, which is going to be our message state that we created above. So our message state is this state right here, right? The one with the this add underscore message reducer. Okay, so we're going to take in that state, and you're going to go ahead and return our message state back as well. Okay, so let me just have it right here, and I'm going to go ahead and say model is going to be equals to our anthropic model. You're going to go ahead and say model name is going to be equals to, and you're going to go ahead and simply, let me just go ahead and simply copy this just to save on time. I have it all the way up here, just here. So I'm going to go ahead and simply copy this. Again, you don't have to define that again. So you just have to say model. We can just use that model directly, right? We don't have to define it again, but I'm going to define it one more time. So model, this is right here, right? And you're going to go ahead and simply do the following. So when you say LLM underscore with tool is going to be equals to model dot bind underscore tools, and you're going to go ahead and pass in our tool, which is our addition tool that we addition tool that we have. And I'm going to go down here and say LLM underscore tool underscore with response. Let me just say response. Yeah, it's going to be equals to the following. So when you say LLM with tool, and you say dot invoke, you're going to pass in our state, right? So state, you're going to get the message part. So message, so message, just like that. Okay, and you're going to go ahead and simply return the following. You're going to return message, and you're going to say message is going to be equals to, and you're going to say LLM, basically sorry, a list. You're going to say LLM response. The reason why I'm using a list is because this is a list, right? Things get added to that list, so that's why I'm using a list right here. Okay, so once I have that, I'm going to run it, and once that function runs, we're going to go ahead and simply import a couple of things to create our graph builder. So we say from LangGraph dot graph, I'm going to go ahead and import message state right here. I'm going to go ahead and import the start. I'm also going to go ahead and import end. I'm also going to import state graph. That's it. So once I have this, I'm going to run that cell, and once that's run, so this is actually building a graph. So building agent graph. Okay, so once I have that done, I'm going to go ahead and simply say builder. It's going to be equals to the state graph builder, and I'm going to go ahead and pass in the message state. So you can see I've imported message state again right here. The reason why I've done that is because this explanation that I've just given you right here of updating the reducers, appending message to the state, is a very common functions. It's a very common thing we do in building agents. So LangGraph already has that already built into it. So I just built it from scratch to show you how it works, but LangGraph already has it built inside. Okay, So I'm going to go ahead and simply say builder is going to be equals to, let's add in some nodes. So add a node right here, and you're going to go ahead and simply add a node. So I'm going to call this tool underscore calling underscore LLM. You're going to use the tool calling LLM function that we just have defined. So tool calling LLM right there, and that's it. I'm going to also add builder dot add underscore an age right here, and this is a normal age. You're going to say start. So from start, you're going to go into the tool underscore calling LLM, and then from you're going to say builder dot add underscore age. You're going to say tool builder tool underscore tool calling underscore LLM, and you're going to go ahead and end right there. That's basically that's the very, very simple graph. So I'm going to create a graph right here. I'm going to say builder dot compile, and then run that. Okay, so I have an error right here. It says found age starting at node. Okay, tool calling LLM. So let me just go in here, highlight that. So this is actually tool calling LLM, not two. Okay, so once I have that sorted, I'm going to go in here and just let's try to display this graph. So I'm going to say from ipy python dot display. I'm going to go ahead and import the phone. I'm going to import display, and I'm also going to go ahead and import image class. So I'm going to go ahead and say display image, and then finally we're going to go ahead and do the following. So I'm going to say graph dot get underscore graph dot draw mermaid jpeg image, and then finally png image, and then finally run that so we can see how that graph looks. So it's a very simple graph. We have the start node, tool calling node, and then end node. That's all we are going to do. So once I have that, I'm going to go ahead and I'm going to do the following. So I'm going to say basically let's invoke in this graph. So let's say invocation, and I'm going to go in here and just simply do the following. So I'm going to say result is going to be equals to graph.invoke, and I'm going to say pass in a message right here, messages, and you're going to go down here and simply say we pass in a human message, and you're going to say content is going to be equals to, and I'm going to go ahead and simply say what is the product, what's the sum of 10 and 20 or 30. That's fine, and you can give it a name, and the name is going to be Prince right there. So that's all we need to do. So once I have it, I'm going to go ahead and run this. Okay, so let me just see. This is actually graph, and I can actually go ahead and print that result. So print result. That's it. So once I have this, I'm going to go ahead and run this. And okay, message. Let me see. I think I made an error somewhere up here. I said message instead of messages. Messages. Okay. Yeah. So let me run that. Build the graph one more time, and let's invoke it again, and let's see what we get back. Okay, so now it's going to take a bit of time, and you can see we get back a message, which is a human response. What's the product of two? And you can see the tool has been called. A message, I will help you add the two numbers, and then you can see all that information. So you can call the tool and pass in A as 10 and B as 20, right, which is very correct. And it's going to return to us, use the tool to return to us the sum of that. So you can actually go ahead and simply say, copy that, paste it in here, and say dot content. And let's run this, and let's see what I think is dot. Let me see if I can remember the right key to use. So let's see. So dot message, and then we have the message right here. Dot content. Yeah. So you can see AI message, and then finally has the content part of it. And yeah, that's basically what we did. So we didn't actually get the response back in this case. So let's go ahead, and you can also look at let's try another invocation and see what we get back this time around. So create another result right here. So result variable, that's going to go ahead and simply say graph.invoke, and you're going to go ahead and pass in the following. So we're going to say messages, and let's see if this time it's going to go ahead and try to use a tool. So I'm going to go ahead and simply say human message, and I'm going to go ahead and simply say content is going to be equals to, and I'm going to say how are you doing today? So how are you doing today? So this should not make it use a tool. So let's see if that's the case. So I'm going to say name, and name is going to be equals to Prince again. And then once we have, it's going to go ahead and simply print result. So we should get back a straight response uh, without having. Let me just go ahead and see if I made an error or something. Okay, so yes, that's it. And if I run this, you can see where we have it right here. And it shouldn't make any tool call because we don't really need any tool. In this case, you can see it just appreciates you asking. I noticed that your question some isn't something I can address using the available tools. The only tool I have access to is an addition tool. So it thinks that it needs to use the tool, but in this case, we're just asking it, how are you? You didn't have to use the tool to try to answer that question. Okay, but in this case, it got confused. Yeah, so that's basically how uh, we have worked with reducers, how reducers can update different messages. And uh, so basically the agent has basically a history or a memory of the previous conversations, right? So you can remember one or two things from the previous conversation, right? Yeah. So you can remember things from the previous conversation and then carry on that conversation, basing on the previous information that it had, right? So yeah, that's basically how you can work with these agents and then update the state and get all that information back. Yeah. So that's basically it. So let me just check out something and make sure that I haven't really see if I can check out something. Yeah, so that's basically what I wanted to check. So once we have this, we can also actually get the state of the graph to see all these messages. That's what I wanted really to show you. So I can just do graph dot let's see, I forgot the name of the method. Dot get state. So actually we just want to get state. Okay, so let's get the state right here and let's see what we get back. So let's state await okay, let's say this. And yeah, for to get the state of the graph, we need a config, and that's something that we'll look at in the next video. Things like memory management and stuff like that. But I believe there's a way we can check this memory, if I'm not mistaken. Yeah, so I would have to take a closer look at this in the documentation, because if you have a config, which is something to look at, you can actually use a config to get specific memory back from this. But basically, because the reason why I want to show you, because right now, if you call this, if you pass it through the tool node, it's only returning to us the message of the AI. You can see it, right? It doesn't show the previous message. So I wanted us to get the whole graph information, so that you can go ahead the whole graph state, so you can go ahead and actually see all the previous information within our graph. That's what I wanted to show you. But in this case, if I forgot the name of the function or how to get this, but I'll talk about this more in the next video when we get to talk about how to work with different routers and how to make a decision between either tool usage or no tool usage. Like you can see right here, there's only tool node. So each time it has to pass through the tool node. That's why down here is telling us I can't give you the sum, because I have access only to the tool node, the addition tool that is used to perform mathematical operations. That's why we are getting that error, because we are always passing through the tool calling node, which always calls the addition tool. And if you say hello, how are you doing, the tool can't handle that, right? So in the next video, we're going to look at the routers and see how we can take decision either between using a tool or basically returning a normal response. So in this case, you ask it, how are you doing today? It should go ahead and tell us, hey, I'm doing good, right? Or hey, I'm doing fine. Thanks for asking. Things like that, right? So we need to go ahead and have a router which decide, okay, does this question need a tool response? That a tool call? If it needs a tool call, then we'll take route A. If it doesn't need a tool call, then we'll take route B, right? Something of that sort. And that's what we'll be looking at in the next video. So guys, I thank you so much for watching. And if you want to connect with me on other platforms, you can find me on Medium, where I also have written articles of these tutorials. You can find me on YouTube, hopefully where you're watching this video, at codewithprince. You can find me on X as well at prince_cramper. You can find me also on LinkedIn if you have any messages, you have any ideas, any recommendations or for future videos. Let me know. You can find me on LinkedIn at Prince Cramper. I'm much faster to respond to you on LinkedIn than any of these other listed platforms right here, or email. So just get to me on LinkedIn if you have anything that needs we need to discuss, right, or suggestions, or anything that you need to pitch to me. Just get to me on LinkedIn at Prince Cramper. Thank you guys so much for watching, and I hope this video helped you so much and you have learned something from it. If you did, the easiest way you can support the channel is just by liking this video, sharing it with your friends and the family who are interested in such topics, and also don't forget to subscribe to the YouTube channel, right? So that this message can get to these videos can get to more and more people, right? So you build a whole community of like-minded people and we all benefit from it at the end of the day. Okay, so if you want to support me further, you can also buy me coffee. The links will be in the description of the video. Thank you guys so much for watching and see you in the next one. Keep safe.